Hello, hi, I'm Nick Burgess. I'm a quant analyst, and today I'm going to talk to you about how to connect Python code to IB Broker for live trading. This is so that we can take Python trading strategies and sort of execute them in a live environment using IB Broker. We've already talked about how to connect Python code to the IB Broker platform. That was in our previous video. Please do see that for connections. And this is the second video now where we're going to talk about how do we get account information, balances, positions, historical real data, so market data and account balances. And then the third video, which is coming right after this, will be orders and execution, how to place trades, how to modify, cancel, track our executions, track our fills, all of that be in the next video. So this video is about the account information, balances, and positions. I'm going to jump into the way it's going to work is I'm going to continue with a PowerPoint series, sort of taking you through how things work, and then I'm going to show you how to do that in live code, connecting to the TWS platform. So please do follow me through the slides and then followed by the actual live coding. So let's go. I'm going to share my screen, and we look at the presentation and then followed by the coding. Give me 1 second. Okay, so run that in presentation mode. Right, so here we are, Interactive Brokers, Python API, and all the links to the documentation are below in the below the YouTube video. This is the second section on account summary information and market data. So these are the things we can do with the Python IB Broker Python API, IB API. So we can get account information, balances, and we get all our balance information, positions information. We can get things very useful to get things like your um, available cash balances so we don't sort of run into margin calls is really important. And then also for backtesting trading strategies, we might want to look at historical data. And for actual live trading, we want to look at real-time data. So we can get market data from the API. We can also then place orders, manage our orders, and track execution. So we can place an order, modify, cancel. We can track the fills. We can track if it's fully executed, track if the order is cancelled, track the statuses, and much, much more. We're going to look at these first two blocks today, and then the next video, which will follow right after this, will be on the order and order management execution. So we looked at already how to connect our accounts from Python, and we had a live example of that. That was in the previous sort of video. This is part two, where we're going to look at how do we get account summary information and positions. So the way sort of Python is working is that we have two classes. We have, just to recap, we have the eClient class, which is sending requests to Python, and then get those responses back, sending the request rather to TWS, and then TWS, the trader workstation from IP Broker or the Ivy Gateway, will send back responses using a callback mechanism. So we listen and we wait for those responses that come back asynchronously. Now, the callbacks that we need to sort of pay attention to for this, for today's sort of video, is we want to request account summary and request account updates. So we send off. That's how we make the requests for account summary and updates. We also then use request positions to get any sort of positions that we're holding, position information, and then so the callbacks we're paying attention to account summary for balances, position for positions, and position and sort of signals completion. So what these last two mean is that we get back our position sort of a lot of the information from Ivy Broker comes back sort of piecewise. So if you ask for market data, for example, you're going to be getting market data. Market data might come back tick by tick. So if you ask for 3 months of daily data, for example, you might get one there. You will get one day at a time. You ask for your positions, you get positions one at a time. And so we need to be told when we've got the last piece of information, and that will then sort of trigger. And that's done for positions by so when you're receiving back position information, it'll come into the position function, the callback. But we need to be told when the last position has been received, and then the code will enter. We get back a position end will be the callback called. So we just watch. So we keep watching and tracking. We have an event to track for when the position end has been called. That tells us then that there's no more positions coming back. And that's so very common. A lot of our methods will come in pairs. We'll have one callback sort of to receive information back, and we'll have another callback to tell us there's no more data to be sent, so that we know we're finished. That's very common to see sort of callbacks in pairs. So please be aware of that. Okay, so in terms of count summary and positions, how would that work in Python? So here I've got, so we create what we saw in our last sort of video was that we have a class where we inherit and we set up, we have a class set up for our app, and that will sort of initialize the eClient and the eWrapper classes, which are the native classes from the Python API. And and then these are sort of extra methods that we're setting up. So these are callbacks that we're going to then update so that we can sort of see the information that's coming back. So what we typically do is we have callback methods, and these are methods that have already been written in the API, and we're going to overwrite them so that we can store the information that's coming back to us, and we can print messages. And so this is our way of sort of capturing the information. So after we make a request for account summary, we get the information back, and we're going to get this. This is the information we're going to get back: the account, the tag, the value of the currency. And if you don't do anything, you obviously won't know you've got the results coming back. So what we do is that once the data's come back, we want to then print the account, we want to print the value, and we want to print the currency. And then we also want to store this information in our account values parameter, which is inside our class. Then when all the account summary is finished coming in, because it'll come in line by line, when there's no more account summary information being sent, the callback will enter this method, account summary and then we will then sort of print we've finished our account summary, and we will try to disconnect. Then likewise, so this is the account information, and then for positions, we will receive back, this is the information we'll receive back, and then we print that out, otherwise we wouldn't know, we won't see our positions. So we print position, the symbol, the quantity, and the average cost. You could also multiply these together to get the value of the position. And then we will append that to our positions data, which you're also storing inside our class. And then we should be seeing a pattern here then. So once all the positions are reported back, so they'll come back one by one, we will then, the code will enter the position and this will be the callback being called. And then once that's called, we will say, oh, that's the end of our positions, and then we'll try to disconnect. Now, and this is what it might look like on my sort of simulation account. So I don't have any positions, so just go straight to the position and then it's printing off my summary sort of line by line. So it's coming into summary once, and then twice, and 4 times. Then when there's no more summary information being provided, the callback will call. IB Broker will call this summary end, and we've overwritten that method so that it prints out that we've finished the account summary, and then try to disconnect. I'm going to show you. So this is some of the methods that I've added to the original code that we saw in our previous video, and I'll show you that shortly live. So next then is to talk about downloading market data. And the way this works is that we create a contract object so we know what market data that we want to provide. So this will be the stock information or the option information. This will be a security information. Typically, you're going to be providing a symbol, an exchange, security type, and a currency. And then once you've created that object and you specified also the data range, the date settings you want to get back. So what I mean by that is say I want one daily data going back 3 months. I need to sort of tell it the date ranges and things I want the date range I want to request. You also have to sort of say if you want bid, ask, trade data. You also have to sort of specify what type of data you want to receive, and that will be that needs to be provided in the request. So this request historical data. You typically provide that request historical data with the contract, and you also provide it with date settings for how much data you want to receive and what type. And the parameters you need to specify the duration string, so 1M for 1 space M for 1 month, 3 space M for 3 months. Bar size setting, that's tick size setting. So I want hourly data or daily data, you can specify that here. And you also have to specify the what to show parameter, which trades for trade data. You can sort of say bid, ask, midpoint. You can also ask for volatility data as well. You have to specifically say volatility for option data. But for prices, you say trade, bid, ask, midpoint are the main codes to use, and you'll see I've documented inside the code what other settings you could pick, and it's also in the documentation. So summarize just to get market data, you specify contract, you provide the contract to the historical data with the timeframes you want to receive back, and then you run it and you'll get your market data. The market, this will make the request. Then you have two callbacks when you receive the data. You receive sort of line by line historical data, and you'll also receive a callback to say when your data when all the data has been received. That'll be historical data end. We'll see that shortly. So this is what a code piece of code might look like. So this is what our original class looks like, where we're implementing, where we're inheriting eWrapper and eClient. So eClient sends requests, eWrapper manages the callbacks. And what we do in the initialization function is that we start then collecting data that we're receiving from our callbacks in our class. And that's so that we can print the data, so that we can display it, manipulate it, and be aware of that data. So the market data I'm going to put into this data parameter, which is a list. And then I'm also going to sort of store the event of when the data is ready. So when we've finished collecting all the data, I'm also going to store an event for connection when the connection is ready. Now you could now the connection, whenever we make a connection to IB Broker always calls the callback next valid ID after a connection has been made. And so that's where I set this connection ready. Using the next valid ID. That's the standard way of doing things. We always check this next valid ID. We use this to confirm a connection's been made. Now, I've written my own get data method. I could have just called request historical data directly, but I've written it as a helper method. So I'm going to take in a contract. I'm going to take in settings. These are date settings, and this is and a request ID. So this is an ID that goes inside there's an ID that we put inside the historical data request because we can make multiple requests. We give it a unique ID. So in this case, I'm always using the number one unless told otherwise. The first thing I do is I clear the data out that I've stored in my class, and then I'm also clearing the data ready method, which is an event. And here you can sort of see me. Here I'm using the eClient method request historical data. This is not my method. This is the API's method. It wants an ID, it wants a contract, and it wants settings. So the settings will be date parameters. And then I've got this data ready method there. So I just check, is my data ready? And then once I've got the data, I'm going to create a pandas data frame so I can sort of view it. And I'm also going to give it a date index. And then I'm going to return that back to the end user. The get data is going to return back a data frame. Now, the other two things just to sort of say is, so I've made a request here, and this will go off asynchronously. So it's made a request, and it's going to wait for the data to be ready, and the data ready is being set in these callbacks below. So what's going to happen is after I've made a request, I'm going to start getting my data back bar by bar, or so tick by tick. I'm going to get data back piecewise. So each and it will come back sort of in order. So bar one will come back in the right order. So you don't have to worry about things like sorting it. So your data will come back, and I'm going to append this to my data. So it's going to put the bar, and it's going to add the date, the open, the high, low, close. It's going to append that to the data object that I've created a placeholder in my when I was initializing the class to hold my data, and I'm just appending that here. So as the data is coming back in, it's being appended to the data parameter, data object, and then once all data has come back, this historical data end will be called. And what we've done there is that we've then sort of update the data ready method. We set it to yes, the data is ready, and that's how it knows all the data's come back. Now at that point, we say, okay, data's ready, and then it'll populate my pandas data frame. So these all, so this is the request callback, sorry, the request method, and then two callbacks will be historical data coming back tick by tick or bar by bar, and then once all data's come back, the historical data end method will be called, and that's the pattern within IB Broker. Within this sort of API, you will be given back sort of data sort of piecewise, typically, and then once all data's come back, it will call the end method, and that's how you know when to no longer wait for data to come back. Now, data does come back very quickly, so it's not a problem, especially if you're working on your local host. So those are the two methods. We're going to see this in code shortly, and then this is how we sort of put all that together and how we use it. So when we're ready to go, we call run. We create an instance of our IB app class, and then we call the connection method, which is what we were sort of going through in the first video. So we make a connection to 7497, which is the demo account. 7496 is for live trading, and we give it a unique ID of 1 in this case. We start the target app run method as a thread, as a background thread, and daemon true means it's the background thread. And we call the start method. And what the app run method does, it starts listening for responses. So we make a connection, but we're not actually doing anything at that point. When we call the app run um, method, then that will then trigger listening, tell our API to start listening for responses and callbacks. Then we wait for a connection to be ready. This is the method that this is populated using the next ID, which we discussed. So we wait for a connection, then we continue. So first thing we need to do is we've got a helper method to create a contract. And it just basically stores this information and calls the native contract class. So we create a contract, and we store it here, contract 1. We're taking in cash 2. Cash 2 is a money market ETF. It's a great place to store your cash when you're not sort of investing it in a trading strategy. So any sort of surplus cash can go in there and earn interest rather than earning zero interest in many brokerage accounts. So the money market ETF, brilliant thing to work with to manage excess cash balances. We can invest in cash ETFs. It's a really good one to use for GPP. So anyway, so we create a contract. We specify cash 2, which is a money market ETF. We say it's classified as a stock. It's on the LSE and it's pricing in pounds. So you specify that as the contract. Settings here. These are date settings. This is just something for myself. Instead of me sort of providing this as sort of individual parameters and passing this around a lot, I just create one settings rather than creating data settings for every symbol. So this is just me sort of trying to sort of streamline things a little bit. And then I call the get data method, and it's going to return a pandas data frame. So app.getData, this is the helper method that we created. It takes a contract, it takes the time settings, and it gives you back a data frame. So you call that. This will then call the request historical data. Also waits for the callbacks, the returning all the data, and then it populates your data frame. Once you've got a data frame, we have a utility method to display that pandas data frame. It's going to display the last 5 rows, so df.tail. You can specify more rows here by doing comma and the number of rows you want to see, and then we also plot data as a simple line chart with a title of the stock. So these are just nice to haves, just to sort of confirm what the data looks like. At the very end of the app, we disconnect and we join. So we can disconnect cleanly. This join will sort of wait for the app run thread to end before continuing. So just a nice clean exit. And that's the overview of the code. And I'm going to take you through that code in a live environment next. So firstly, let's show you on the chart what that looks like on the PowerPoint slides. We're calling these methods data settings. So we create a contract, create the time setting. So in this case, you want one daily data for 3 months. We're going to show trade prices. You can also sort of say bid, ask, midpoint. We can also request volatility in the same way. And then once you call the get data method, it returns back a pandas data frame, which we can display and plot. And here's the example for what the cash 2 values were for the last 5 days. You see 1st of August here. And here's the line plot. And it's a fantastic sort of way to sort of invest your cash in a money market ETF. Cash 2 for sterling investors. Any surplus cash can go in here in a very healthy sort of around 5% interest. It's accumulating ETFs. You can sort of see no payouts. It's just reinvesting cash. So you get compound interest. It's a fantastic ETF to work with for surplus cash balances. And then we have some resources here. So this resources here will the top one is going to show you all the callback methods, all the functionality. It's going to give you a lot of detail on what methods are available in the official documentation, which is the first one. Algo Trading 101 is just sort of telling you how to sort of get started and all the 101 basic methods. And then this API course at the bottom. These are video training classes on all the features. That's very useful. And then we're going to come back to the closing remarks after I show you the live trading, which now. So in terms of looking at how we run this code in a live environment, firstly, here's the TWS trading platform that I'm connected to. It's a simulation account. And then I'm also going to show you my code. my Python code, which is here. Account summary, very straightforward. This is sort of recapping what we just sort of said. So here you can see me, I'm importing the eClient and the eWrapper. So eClient sends requests, eWrapper receives callbacks. This is then you create your own class of it, inheriting these two and initializing them. And then you start, and in the initializer, you store all the information that you want to capture. So in this case, I'm capturing account values, positions, and then I also want to track, has my account summary finished, my positions finished, and am I disconnected? We typically always work with this next valid ID method, which tells us which is always called after a connection is made, and so that way it's a really good way of tracking whether we made a connection. We usually use this method. Now the callbacks we're using for that we get for account summaries is that for each sort of piece of account information, it will send it back through this account summary callback, and then the account summary method end will be called when the last account summary information has been set. Likewise for positions, when you're requesting positions, it will come back through this position method, and when after the last position has been sent, it will call this position end method, and we're basically overwriting and store these methods to store the information we need to store, and that's the common pattern that you're going to sort of see in the IB Broker API. So you make a request, and then we override the callbacks to capture the information. So this account summary information, I'm going to store the account values. I'm going to populate the parameters that we set up in our initialization sort of method through these callback methods. And then once there's no more data to receive, we'll populate the method so that in this case, the account summary is finished, and we'll also try and disconnect. And when the positions are finished, we'll also sort of say it's finished and then try to disconnect that as well. It won't disconnect until everything is actually finished. That's why it's called try. So we'll wait for account summary and positions to both finish before actually making a disconnection. That's how this particular piece of code has been set up. Here you see me running it down here in a loop. So you see me running it. I make a connection. I call the run loop, which calls the app.run, which is the listening class is being run in a loop as a thread in the background. And then once the initializer, we make all these, we make the request, so you see here in the next valid ID, this is probably the important part. This is what triggers the request. There's so many ways of doing this, but what we've done here, which is you see quite a lot of people doing, is that next valid ID is always called immediately, sort of once you make a connection. So what we do here is we say we're connected and we show the valid ID, and then in this method we can call everything we want to call. You can call it explicitly, but this is always going to be called. So instead of me writing sort of request account summary, request positions, if that's something I always want to do on every connection, you can put it here. If you want to just do it once, outside of that, just place it somewhere else. But what we've done here is we're saying on every connection, print me the account summary and print me the positions. So this is something we do every time we connect. So when we make this connection and we call the run method, it's going to tell us that we're connected. And then we're going to request the account summary request positions. So that's going through the client, and then the eWrapper callbacks. Once it's going to start sending us back the account summary synchronously, we'll print out each line of account summary, and once it's finished, we'll also print out that there's no more account summary to come, and we'll also specify that the account summary is finished. That parameter will update to true. And we'll do the same thing with positions. So we've made a position request in the next valid ID, which is always called in this connection. Once the data comes back, we'll print out sort of line by line the symbol, quantity, and the average cost, and then we'll append that to the positions list, which you have in the initial, which is one of the parameters in our initialization function. And then we try to disconnect with we got positions, and when the positions have ended, we sort of say, yes, no more positions. We flag the positions finished as true, and then try disconnect. It looks into our parameters of the account summary finished, have the positions finished. If they're both true, then we sort of say we've received all data, and now we say disconnected true, and we'll make a disconnection. And so what that means is that when we're actually running our code, it's actually very pretty looking. It's always going to request account information. It's always going to display positions. And and then it's going to disconnect once that data is in. So it's not going to keep the connection longer than it's needed to keep it. So if you go over here into, you can sort of see our positions values 1.1 million. So we've got $1 million, sorry, 1 million sterling in this account, a little bit more than 1 million sterling. You can see, I'll pull up the data so you can see our connection. So there is no connection. We're going to connect with client ID 1 in this case. So let's run this code. So I'll run the, so that's explaining it, then I'll run it. So I've implemented the class here, and I'm going to run it here. You see it's made a connection with client ID 1. It's already disconnected because all the data's come back. And what it's done is we always say error for console output. It's not, these are not actual errors. It's just telling you it's printing something to the screen. So it's connected to all these different data farms. It's finished finding positions because there weren't any positions. In this case, there aren't any there's no positions I'm holding in my simulation account. It has printed off everything I've asked it for though a bit. So I've listed out all these are all the things I wanted to get. They've come back. So available funds, 1,083,841, and buying power is this, net liquidation here, total cash value here. And if you sort of look in your account, you can sort of see all of that's correct. So it's returning back all of this. Oops, let's close that. Count window. This is really important. The current available funds, current excess liquidity, that's really important. So definitely want that information coming back because that's telling me I'm going to get a margin call when this goes to zero. So we want that current available funds, current excess liquidity. We want that to be as far away from zero as possible because once it gets to zero, you're going to get a margin call. So that's very important to get some of this current available funds back. Is really important. Probably should have asked for excess liquidity. Is probably that's the one I'm after, but they're the same in this case. So that's us getting back the account information. Now for market data, which is very, very similar. So in this case, I'm going to work from the user case backwards. So because I think it's more intuitive that way. So we're going to make a connect. So firstly, we're going to initialize our class. We're going to connect. Then we're going to run we need to do app.run. That's going to tell our app to start listening for callbacks, and then we start the thread. It waits for a connection to be made, which is the same as what we did before. Now, in this case, like I said in the PowerPoint presentation, I need to create a contract. I created the cash2 ETF here. So give it the symbol, tell it it's a stock. It's classified as a stock on the LSE and currency is in GBP. Time settings, I'm going to ask for 3 months of data, daily data, and I want that data to be traded data, transaction levels. I could ask for bid, ask, or midpoint. Those are the other things we could also ask for. There's similar things for volatility. Then you request the data and you get back a pandas data frame, and then once I can display that data frame and I can also plot it, and that's what you sort of see below. I see some plots. I'll run this shortly. And this is exactly what I said on the PowerPoint slides. So it calls this get data method. The get data method runs makes a request. And then the callbacks when the data is coming back, you'll get back to tick data or bar data, and it'll append that to the data that data parameter that we've specified in our initialization sort of method. And once all the data's come back, Python will call this historical data end, and you see the data ready is all the data's ready set. And we've overwritten the methods here, so that when the data is coming back, we append it to our data object, and we also sort of say that our data is ready when the last piece of data has come through. So we always have a data method and a data end, a very convenient way to know you've got all your data. Now the contract itself, this is a helper method I've created. It's basically I call the IB API contract class. It's an empty one here, and then I just append the symbol, security type, all the information there. So this is just a helper method just to sort of make the code less verbose. Data settings as well. There's quite a lot of data settings. I'm only sort of populating some of the basic settings because that's all I need for in my scenario. So in my case, I just want 3 months of daily data. So I only need 3 parameters what I need for time settings. In terms of how much data to ask for, and some helper methods to display and plot. So that's the overview of the code, same as what I showed you in the PowerPoint slides. So so we've initialized, we've run the code class. Now I'm going to run the demo, and you can sort of see it's pretty quick. It's made the connection here. These errors are just to sort of say console output. It's connected to all these databases of data farms. It's connected with order ID 1, and now you can sort of see it's plotting the last 5 days worth of data, and it in so it's telling me what the last five values are, and then it's also making a plot. And that's exactly what we see. And this is very nice for Cash 2. It's very lovely to see. Um, and so I've got Cash 2 money market ETF being displayed. And I've also asked for Apple and NVIDIA data, and you can sort of see all of that coming through here. Apple's looking very good at the moment. And you can sort of see, if you go back into the running sort of code, I've asked it for just one single, asked it to get the data just for one contract. But it's no problem then to sort of iterate over that in a loop and ask for many contracts. So in this case, I've asked for Apple and NVIDIA 1 day data, 3 months data, 3 months of daily data, trade, giving me the trade levels. And then once I've done a disconnect and close the app run thread, then we're all done. So that's us showing. So obviously, when I'm running a code, you can sort of see the connections sort of happening here. You see it's client ID 1. It's when it's finished, it disconnects. Very, very nice. So that's taken care of very well. You can see my cash balance is actually what it was. I'm not holding any positions in this case. They'd be displayed here. Those would display. And so we've given an example of how to connect to our, in this case, our simulated account. If I switch to the port 7496, it will connect to our live account, and it'll pull back live cash balances, margin call levels, and make the connection to the database. It'll also then, using this market data code, we can sort of download historical data over any time period we want, and plot and display and do whatever we want to do with that data. So typically, we want to use that for back testing. So we've gone over how to get the account summary and market data. Jumping back then to the PowerPoint slides, just for closing remarks. Please do try everything on simulation accounts before you do things live. Please do start small and do plenty of testing before placing orders. And then last thing to say, if you want to sort of subscribe to my Quant YouTube channel, please do. I do post regularly on algo trading and quant research, and I have a free newsletter as well. And follow me on LinkedIn should you want. I'm very active on LinkedIn, posting live quant research there as well. So our next video, we're going to look at placing orders and order management, how to place trades, how to modify, how to cancel orders, how to check execution status and order status in general as well. That's coming up right after this video. All the materials presented here are below this video in the links. Please do subscribe to my channel. Thank you very much for your time.